Hi, in this video, I solved two unanistic problems in transients which was asked in the year April-May 2019. The first problem is, let the switch in the circuit shown in figure maintain its position A for a long time. At time t is equal to 0, the switch moves to B. Determine V of t for t greater than 0 and calculate its value at t is equal to 1 second and 4 seconds. Okay, this is the circuit diagram given for this question. Okay, here we need to find the voltage across the capacitor. This is the question what they have asked. Here we are having two sources. One is 24 volt and another one is 30 volt and have two switches and three resistances and one capacitor. Okay. This sum is divided into two cases. The first case, when the switch in the circuit maintains its position A for a long time. If the switch is connected to the A position and maintains a long time means the capacitor gets fully charged and it will become such a open circuit. So the circuit can be redrawn for the understanding purpose by eliminating the position B. And we got only 24 volt 3 kilo ohm in series with 5 kilo ohm resistance, and here we are mentioning the open circuit possibilities by removing the capacitor. Again we can read down this diagram for understanding purpose. Here we are having only single loop, that loop contains 24 volt and remaining two resistance are in series. Here we need to find out the voltage across capacitor. Voltage across capacitor or voltage across open circuit. Now this voltage, we need to find out the voltage across 5 kilo ohm resistor. It will provide the value of voltage across open circuit. Okay. Using voltage divider rule, we are finding the voltage across 5 kilo ohm resistor. V5 is equal to total voltage into particular resistance divided by total resistance in series. Now we got the answer as 15 volt. So now we are considering this voltage drop across 5 kilo ohm resistor as a voltage across open circuit and also a voltage across capacitor. So we are indicating that particular value as Vc of 0 is equal to V5 is equal to 15 volt. So this is considered a initial voltage across capacitor. So this is the value found out in the first case. Okay, according to the question, we need to move the switch position to B at time t is equal to 0, and the circuit can be redrawn as, see this, if we move the switch to position B means this 24 volt and the 3 kilo ohm 5 kilo ohm resistance are eliminated. Only we are having the capacitor and 4 kilo ohm resistor and another 30 volt power supply. That is alone we drawn here. Okay, see this diagram. Here we are having the capacitor 0.5 millifarad and 4 kilo ohm resistor and 30 volt. Now we try to solve this circuit using Kirchhoff's voltage law. 30 is equal to voltage source. 30 is equal to resistor or I of t. Here resistor is 4 kilo ohm, so 4k into I of t plus voltage across capacitor. Then here in series current is same. So the current through the capacitor is denoted as I of t is equal to C dVc divided by dt, and the value of capacity is 0.5 millifarad. Then we are substituting here, instead of I of t, we are substituting c dvc by dt plus vc of t. Then we are substituting the capacitor value 0.5 10 to the minus 3. Here also we are having 10 to the power 3. 10 to the power 3 and 10 to the power minus 3 will get cancelled. The remaining values are displayed here. After that, we are taking a Laplace for this equation. The Laplace transform of constant term is 1 by s. Here the constant term is 30, so we made it as 30 by s is equal to, for differential term we will write the Laplace equation as s vc of s minus vc of 0 plus vc of s. Afterwards, for vc of 0, we are substituting the value found out from the case 1, because this is the initial voltage across the capacitor, that value is 15, we are substituting here. Okay, then we are solving those problems, and finally we are taking some LCMs and cross multiplications. After that, we will get VC of s is equal to 30 of s plus 1 divided by s into 2s plus 1. Then removing the value from the removing the value in front of s 2, we are making the 2 outside, so we get s plus 1 by 2. Then we will get the term as s plus 1 divided by 2s plus into s plus 0.5. And again we are shifting this 2 to the above numerator term, means 1 by 2. 1 by 2 we can able to write it as 0.5 into s plus 1 divided by s into s plus 0.5. Now we have two denominator values. One is s and another is s plus 0.5. By using partial fraction, we can able to find out the values. Okay, in partial fraction, we split the two denominator terms into a by s plus b by s plus 0.5. After that, using equate method in partial fraction, we are equating a by s is equal to this whole term. While we are equating, the same denominator values will be cancelled. The s and s will be cancelled. The cancelled values is equal to 0 means we get the s is equal to 0. Now we are substituting s is equal to 0 in these cases, and we get the value as a is equal to 1. And to find out the b value, again we are substituting b divided by s plus 0.5 is equal to this whole term. Now the common term gets cancelled. Here the common term is s plus 0.5, it will get cancelled, and those cancelled term we can equate to 0. So s plus 0.5 is equal to 0 means we got s is equal to minus 0.5. Now we are substituting those values to s. We got b is equal to minus 0.5. Now we got both values a and b, and substituting those values in the first equation. We got Vc of s is equal to 1 by s minus 0.5 divided by s plus 0.5. Now we are going to do the Laplace inverse. The Vc of s gets converted to Vc of t, then 1 by s, Laplace transform of 1 by s is 1, and the Laplace transform of 1 by s plus a is e power minus at. So we are having 1 plus 1 divided by s plus 0.5. After taking Laplace inverse, we will get e power minus 0.5t. Okay, this is the final answer we got for this question. But they asked, in this question they asked, determine v of t for t greater than 0. V greater than 0, and also to calculate the value for time 1 second and also for 4 seconds. So we are going to do this. Okay, after getting the voltage across capacitor term, we are substituting the time value for 1 second and 4 second, that's all. For at t is equal to 1 second, we are substituting the t value as 1 and we got the voltage across capacitor at time 1 second is equal to 0.69675 volt. And also similarly for 4 seconds we got VC of 4 is equal to 0.9323 voltage. Okay, this is the end value for this particular sum. Okay, now we move on to the second problem.